Alright guys, in this video I just want to talk a little bit about how you can translate graphs between different types of graphs is what I mean by that. And there are really three types of graphs. We've only talked about two of them, but the third type is pretty simple. For at least it's simple in this course. Three types of graphs. The first one we talked about was the position time graph. And the second one that we talked about was the velocity time graph. And the third one that we haven't really discussed that I'm just going to mention briefly is an acceleration time graph. So just so we're clear on how each of these works, the first thing that's stated is always the one that goes on the vertical axis, or what we sometimes call the y-axis. And the second one in the title, which is always time, the time is on the horizontal axis, or what we call the x-axis. So, for instance, an acceleration time graph would be a graph where you have acceleration on the vertical axis and time on the horizontal axis. Now, I mentioned for the purposes of this course, these graphs are really simple, and that's because in this course, the acceleration will always be constant. The acceleration is constant in value, which means that the only kinds of lines you can have here are lines with zero slope. Now, in other physics courses, you will deal with non-constant acceleration where the slope won't be zero, but there are only basically three situations we could have. We could have a situation of zero slope like this right here. Maybe I'll make that slightly bigger so you can see it. We could have a graph like this here, right? This would be the case of acceleration being exactly equal to zero. Or we could have a case like this, where the acceleration is greater than zero. It's a positive value, in other words. Or we could have a case where we're down here and the acceleration is less than zero, which means it's a negative value. But those are the only three kinds of accelerations that we're going to deal with in this course, because they have to be zero, again, which means zero slope. But what I want to talk about in this video, now that I've just quickly introduced acceleration time graphs, is how you move between the different types of graphs. So for instance, maybe we could take a look at these three graphs actually really quickly. For simplicity's sake, maybe I'll just start fresh here. So let's start with three cases here. I'm going to draw an acceleration time graph. I'm going to draw three of them, the three ones that we just had. Acceleration time. I'm just going to sketch three here real quick. Acceleration time. And we had three cases before. We had the case where the acceleration was zero. We had the case where the acceleration was not zero and it was positive. And then we had the case where the acceleration was not zero, it was negative. So what would these three graphs look like or how would we translate these into a velocity time graph in each case? And then later we'll do position time graphs. So we're just translating these into velocity time graphs. Okay, so let's start with the first one here. Well, what do we have here? Well, we have here that the acceleration is zero, which means that the velocity can't change. So I'll write the delta v, because acceleration means change in velocity. That means the delta v, the change in velocity, is zero, which means that the velocity has to be constant. Now, I want to point something out. Well, what does that mean for a velocity time graph? That just means that the slope is going to be zero. Has to be zero. Because on a velocity time graph, the slope is the acceleration. So actually, maybe I should write that. I'm going to say the slope, remember, on these graphs is the acceleration. On a velocity time graph, the slope is the acceleration. So if the acceleration is zero, that means my slope here has to be zero. So what would a line of zero slope look like? Well, it could look like, I'm just going to make this a little smaller. It could look like this. That's a line of zero slope. But so is this. And so is this. Right? Those are all lines of slope being zero. So which one of these lines that I just drew corresponds to this graph that we started with up here? Well, it turns out they all do. All right, all of these three lines that I drew, 1, 2, and 3, any of those three are consistent with that graph because they all have, since the acceleration is 0, they all have to have a slope that's 0. So any of those work. Okay, you don't have any information in the acceleration time graph. We didn't know what v initial was. That's unknown. We don't know what the initial velocity is. So any of these is acceptable. All right, let's take a look at this one over here. Well, what do we know here? Here we know that the acceleration is positive. It's a greater than 0 acceleration, or a positive acceleration. And again, what does that mean? That means that the slope here, since the slope is the acceleration, it has to be greater than 0, right? If the acceleration is greater than 0, then the slope here has to be greater than 0. So what does that mean? Well, it could mean this. That's a slope of greater than 0, but so is this, and so is that. Again, any of these three would be acceptable. Any of these lines that I've drawn here, 1, 2, 3, any of those would be an acceptable translation of the acceleration time graph because they all have a positive slope. Going over here, in this case, we had the acceleration. The third case, we had the acceleration is less than 0. So that means down here, again, my slope has to be less than 0. So it could be slope less than 0 like this. It could be slope less than 0 like this. It could be slope less than 0 like that. Any of these is acceptable as long as it has a slope less than 0. One point I'll make quickly, you'll notice that all of these lines were straight lines, right? These were all straight lines. And that's important because straight lines on a velocity time graph mean constant acceleration, right? If the slope is the acceleration, on a velocity time graph, and the acceleration is constant, then the slope has to be constant. So we're only going to have straight lines here. I'll just point that out. We won't ever have curvy lines on a velocity time graph. All right, so far so good. So let's take a look at, I'm just going to erase this to make some room. Let's take a look at corresponding position time graphs. And maybe just to make my life easier, I'm going to get rid of, I'll get rid of this. I'll just do one in each case. Maybe we'll get rid of that one, and maybe I'll get rid of, I don't know, maybe I'll get rid of this one here, and I'll do that one. And then which one do I want to do here? Maybe I'll do this one just to make things a little bit simpler. Okay. So I'm going to draw now position time graphs. Position time graphs. So in each case, the position time graph that I'm going to draw will correspond to the velocity time graph above it. So just like before here, maybe I'll just put a little dotted line so we, oh, sorry about that. Just want to, there we go. Just going to put a little dotted line right here. And now if I take a look, if I zoom in, I want to draw a position time graph here that corresponds to this line above. So what do? Well, I'm going to remember, as we did before, that on a position time graph, the slope is the velocity. So on a velocity time graph, we said the slope was the acceleration, but on a position time graph, the slope is the velocity. So here, I've got a case where the velocity is greater than 0. So here, my slope has to be greater than 0. So it could be something like this, or this, or this, as before. The only information I have from this graph above, the only information we have here is that the velocity is greater than 0. So the slope has to be greater than 0. If I take a look here, once again, what do I have here? I've got a case where the velocity is increasing, right? This is increasing velocity, right? The velocity starts at 0 and it goes to some positive value. We could make some number up. I could say this is positive 3. So in this case, because the slope is increasing here, the velocity is increasing. Okay, well that means, sorry, since the slope is positive, I'm going to back up and say that this is a positive slope. And positive slope means positive acceleration. Positive acceleration means increasing velocity. So what does that mean? Well, if the velocity is increasing, that means here the slope has to be increasing. Now, what I'm going to do here is, since I noted right here that the initial velocity in my graph up here was 0, I need to start with 0 slope. And I can start anywhere I want. I'm going to just arbitrarily choose to start here. Doesn't matter. I don't know what the starting point, what the starting position x is in this situation. But I do know that the initial velocity is 0, which means my initial slope has to be 0 slope. Right here I'm writing 0 slope, because the slope has to be 0 because the initial velocity was 0. And then since the velocity is increasing, then the slope has to be increasing. So it starts at 0 and it gets bigger and bigger and bigger and bigger and bigger. So it's going to be curved. We call this concave up. It's curved upward. So upward curve, because the slope is increasing. Okay, the hill is getting steeper, essentially. So lastly, we take a look. You might see where we're headed in this last one. In this case, we had the case where the slope was less than 0. It's a negative slope, which means that the velocity is decreasing. It starts again, in this case, at 0. Here is v initial is 0. But it's becoming negative and negative and negative. And again, it goes to -1, -2, maybe -3 down here. So it's getting more and more negative. So once again, I can start my line on my position time graph anywhere I like. I'm going to arbitrarily maybe just choose to start at the origin this time. The initial slope has to be 0 because the initial velocity was 0. And then it's going to get negative. What does that mean? That means it's going to curve downward like this. So it's a downward curve. All right, so the key to doing these translations, and these translations can be really quite tricky. You will do a little bit of practice with them, but the key to remember, and I've said this now, I feel like in this video probably 20 times, the key is the following. On a velocity time graph, let's maybe write this out as takeaways. The main takeaway. Number 1, on a velocity time graph, the slope is the acceleration. And on a position time graph, the slope is the velocity. Okay? So these are, I'm going to call these the main takeaways. And if you can remember these two things, and if you know how to use them properly, you can do any graph translation in this course.